Since we've talked about the three-dimensional Cartesian planes, or Cartesian plane, that gets us into vectors. Specifically, we're going to be looking at vector relationships in space. Now, most of you are probably thinking of Despicable Me and how his name is vector, and it's both direction and magnitude. That's partly true. In math, when we're talking about it in space, space has a three-dimensional characteristic. So a vector is a little bit different because we have 3 dimensions, not just 2. But realistically, a vector is just a directed line segment in that x, y, and z plane. So a vector is written in terms of v1, v2, v3. Okay, and those are just directed line segments depending on the axis, whether it's x, y, or z. With that being said, there are several different relationships that we need to discuss. First one is the addition one. Addition is pretty straightforward. Let's say, for instance, that I have an actual, let's go with 2 different vectors. If I have v is 1, 3, and -1, and w is positive 2, 0, and -2. Okay, so if I want addition, this is pretty straightforward in the sense that you just actually add them according to their locations. So I would have 1 plus 2 to give me 3, 3 plus 0 to give me 3, and then that last one, -3. Okay, straightforward. Subtraction is pretty much the same thing. Straightforward. So I'd have -1, 3, and then 1. Magnitude. So this is where we're talking about you need magnitude and direction. The magnitude is represented as an absolute value. I'm just going to do it with just the v vector for this one. What you're doing is you're taking the square root and then squaring each one of those coordinates. So realistically here, I've got 1 plus 9 plus 9 to give me the square root of 11. And it's the absolute value because obviously when we're taking the square root, you could have a positive or negative, but magnitude is giving you a distance pretty much. We also have a dot product. Dot product is kind of like multiplication, but it's a little bit different, where you're actually going to get a true number. When you're doing this, you're multiplying, so I would take 1 times 2 plus 3 times 0 plus -1 times -2. When I get this, I'm then going to get a final answer of a number, kind of like how I have one for the magnitude. I have a final number. So on this one, I get a final number of 4. And then the last one is a unit vector. And that's taking your v divided by your magnitude. I'm not going to go through an example of this one because this one you don't use as often. But all you're doing is looking for those different relationships and just calculating that different math. There are ways to find the equations of lines based on this, but we're going to be looking at that later because it's dealing with parametric equations and we haven't gotten to that point.